the next part is not really a lecture, but a series of little exercises that I'm going to explain, but I suggest that every time, with every new slide, you pause the lecture and you try to answer it, well, at least as a brain teaser, and then you listen to my explanation. All right, so here, notice the following, that the right-hand side sometimes is positive, sometimes is negative. While if you look at the direction field, then all the arrows, they point kind of upwards. So here, in this plot, y prime is always non-negative. So which means this is out. And further, this equation is autonomous, while in the direction field, we do not see it. For example, if we look at this line, then arrows along this line are different. They're not all the same. So this is out, this is out, this must be right. So again, maybe you can pause the lecture and figure it out. Okay, so now, by looking at this differential equation, it is a linear differential equation, and the homogeneous part is y prime plus y, which means we are going to have its general solution is going to be some particular solution plus the general solution of the homogeneous problem, and the homogeneous problem, y prime equals y, of course you know it very well, c to the t, c times e to the t. While here, the homogeneous part is y prime equals minus y. So here the general solution is going to be the particular solution plus c e to the minus t. In other words, the first equation, as t goes to infinity, e to the t diverges, so all solutions are going to drift away from the homogeneous solution. In the second example, all solutions are going to drift towards the homogeneous solution, and this is what we see, right? So we see some kind of a pattern here, but all other solutions, they kind of go away from it, while here we have some oscillation pattern in the middle, but the rest of the solution, they converge towards it. So which means that it is this, it is this. Wow, how about this one? And again, can you pause the lecture and try to figure it out? Okay, and now let me explain. Positive numbers, negative numbers, which means that the first system of equations can be thought of as a model of two species that cooperate for mutual benefit. So if x is the population of the first species, 2 is the population of the second species, then they help each other, which means the presence of the other species is helpful for our own species. And of course, in practice, it means that the population of both species would be bigger than it would be otherwise. So the population of these two species without the other species is 3 and 2 respectively. So if the species did not interact, then the equilibrium solution where both species are present would be here. But since the actual equilibrium solution is here, and we see that the populations are larger, it means that it is the case here, while in the other system, the coefficients are negative, which means this is a model of species competition, and now the equilibrium solution would be smaller than the equilibrium solution that we would have without, if the species did not interact. So, therefore, it is this. Wow. again, pause the lecture, try to figure it out. Now, let me explain. So, note the following. Note that this number here is the same as here, and the rest of them is the same. So the difference is in this coefficient. And this coefficient shows the bad influence of y on x. And at the same time, we see that in the right plot, there exists an equilibrium here, where both species are present, although it is non-stable. But in the left plot, it is just not here. So in the left plot, the only stable equilibrium that we see is here, where only x is present, but y is extinct. So y is extinct. But now we have to choose between two situations. In both cases, the bad influence of x on y is the same. But in one case, the bad influence of y on x is smaller than in the other case. So, of course, if the bad influence of of y on x becomes smaller, then y gets a smaller chance to survive. So which means that if y is extinct here, then it must be this. Because in the second system of equations, as compared to the first, y is less competitive because its bad influence on x is smaller. And here, y is more competitive, so which means it stands a chance to survive. And again, so which of these plots shows a sample of solutions of an autonomous ODE? So autonomous means that if you move it to the right or to the left, then you again get another solution or the same vector field. Right? So in the first plot, if you move it, say, to the right, then you would have this, and this is not allowed. In the second plot, if you move it to the right, you would have this, and again, this is not allowed. But the third plot is okay. Now, each of these plots shows a sample of solutions of a differential equation. So one has order 1, another one has order 2, and the third one has order 3. Which is which? Think. Okay, now let me explain. If you look at the first plot, then here, two different solutions, they touch each other. So the tangent line here to two of them is exactly horizontal, which means they share the same value and the value of the first derivative. And this would be inconsistent with order 1 or order 2 because it would contradict the existence and uniqueness of solutions. So which means here the order has to be at least 3. Now, here solutions intersect, which is not consistent with order 1 because of the same thing. So which means here the order is 2, sorry. And therefore here the order is 1. So solutions of differential equations of order 1 cannot intersect. Solutions of differential equations of order 2 cannot touch. Wow, that's a hard one. But this one I will not tell. So try to figure it out at home and post your